Hello everyone. Today we are going to learn how to perform division in other bases. Now, as always, I'm going to start by going over the steps of division in base 10 because the process of division in other bases is going to be similar to the process we follow in base 10. So let's pick two numbers to divide. So I'm going to use this number here, 321 divided by 5, right? So we start by taking two digits in this case because the first digit 3 is less than 5, all right? So what we are dividing should be equal to or greater than the divisor. So we take two digits, 32, and then we have to think of a number when multiplied by 5 will give a value as close to 32 as possible without going over. All right, so we use our multiplication tables and we see that 5 times 6 is a 30, correct? So 30 is as close as we can get to 32 without going over. So what we do is we take this 6 and write it on top, and then we take this 30 and write it below the 32, all right? So 32 and then the 30, and then we subtract the two values. So 2 minus 0 is a 2, 3 minus 3 is a 0. So next step is to bring down the 1 and write it beside the 2 to get a 21. And we continue the same process all over again. Think of a number when multiplied by 5 gives us a value as close as 21 as possible. Again, use your multiplication skills. We know 5 times 4 is 20, and that's as close to 21 as we can get. So we can write the 4 next to the 6, and we write the 20 below the 21, and we subtract. So 21 minus 20 is a 1. So we don't have any more digits to bring down. So we can stop here. 1 becomes our remainder, whereas the 64 is going to be our quotient. It's the quotient. All right, so we are going to follow the same steps when performing division in other bases. So I'm going to work through some examples, a couple of examples. So that should give you an idea how to go about dividing in other bases, right? Now for the first example, I'm going to work on dividing two base 5 numbers. So the numbers I've chosen are 302 base 5 divided by 4 base 5. All right, so we'll follow the same process as in division in base 10, but remember this time we are working in base 5. All right, so we'll think of a number. We have to think of a number in base 5 when multiplied by 4 gives us a value as close to 30 as possible without going over. All right, so I have 4. If I pick 4 times, and we have to do some trial and error at this point, let's pick 4 times 4. Now for the multiplication part, I'm starting off as in decimals, as if I'm working with decimal values, and then we'll have to convert that to base 5 values. All right, so that's how I'm going to work. So let me just choose 4 times 4 and see. 4 times 4 in decimal is a 16, correct? Now 16, again, this is a base 5 value, so we have to create bundles of 5. So how many bundles of 5 do we have in 16? 16 can be written as 3 bundles of 5, correct? 3 bundles of 5 plus 1. 3 bundles of 5 plus 1 here. So this is 3 bundles of 5 plus 1. So that would make the number 31. We have a 30, so it's gone over. So go to the next lower number, multiply 3 with 4, and see whether we get a number in base 5 as close to 30 as possible. So now I'm going to, this doesn't work. All right, this didn't work. So 4 times 3. Now 4 times 3 is 12, but this is a decimal value. I have to convert it to base 5. So we have to see how many bundles of 5 we can create out of 12. So we have to represent the 12 in base 5. So we have 2 bundles of 5, right? 2 bundles of 5. All right, so that makes it 2, and then plus the remainder is 5 plus 2 makes it 12. Remainder is 12. So the value is 22. All right, so 22 base 5 is the equivalent of 12 decimal. All right, so we can work with that. 22 base 5 is close enough to 30 without going over, or is the closest we can get to 30 without going over. So we are going to write this 3. We are going to write this 3 as the quotient, or rather the part of the quotient. I'm going to write the 3 as part of the quotient. And this 22 base 5 has to go at the bottom of 30. Sorry, it's 22 base 5. All right, it's wrong really to say 22. 22 is a decimal verbiage. All right, so I put 2. So now we have to do the subtraction process. So again, for the subtraction, remember we are working in base 5. So the digit in the rightmost column above is a 0. So again, use or recall your subtraction rules, carryover rules, when you're doing addition. Well, this is subtraction, so borrowing rules, so to speak. All right, so we have to borrow from the 3. And what happens when we borrow from the 3? The 3 becomes a 2, and the 0 becomes a 5. All right, well, we borrowed 1 from 3, but we have to unbundle. So if you've watched my videos, I have used the term unbundling. So let me go over the subtraction process one more time here while we are working on this division problem. From the 3, we borrow we borrow a 1, a bundle of 5, so to speak. So the 3 becomes a 2. And when we give 1 bundle here, oops, sorry about that. Just a second, let me get back my writing. So when we give 1 bundle here, it's actually a bundle of 5s, correct? Base 5, there were bundles of 5. So when we do the subtraction, we are actually subtracting from the unbundled pieces, which is 5 minus 2. All right, this is just reviewing the process of subtraction, which you should have watched earlier. All right, so 5 minus 2 is a 3. So I'm going to write the 3 here. And 2 minus 2, all right, we change the 3 to a 2 because we gave away 1 to the right column. So now we have 2 minus 2 is a 0, all right. Now in the next step, we have to bring down the rightmost digit, which is a 2 in this case, the next digit to the right rather, bring down the 2, and then continue the process all over again. All right, so now we have to find a base 5 number when multiplied by 4 will give us a value as close to 32 as possible. All right, so 4 times 4 would seem to work, correct? We had already tried that for the previous step, but it didn't work when the value was 30, all right? But it might work for 32, and in fact, it does, all right? So 4 times 4, and I'm going to repeat the same thing down here. So 4 times 4 is 16. So we have to see how many bundles of 5 we can extract out of 16. So we have 3 bundles of 5, 15 can be bundled into 3 plus 1, correct? So that's equal to 31 in base 5. So I'm going to write my 4. This 4 is going to go up next to the 3, and this 31 base 5 is going to come below 32. So 31. All right. And now we perform the subtraction. Fortunately, we have a digit which is larger than the digit at the bottom. So 2 minus 1 is a 1, and 3 minus 3 is a 0. Therefore, the subtraction is, the division is completed at this point. There are no more digits to divide. So the remainder is a 1. All right, remainder is a 1, and the quotient is 34. So the way we write our answer is, answer should be written like this: 34 with a remainder of 1. All right, this should be how you write the answer from this division. All right, so I'll work through another example in a different base to just reinforce the process of division in bases other than 10. All right. Now for our next example, we will be dividing two base 8 values. But before I get started with the division, I just want to go up to the example above and make an important note here. When I wrote the final answer, I didn't put the base values as subscript. It's very important to do that, because if you do not put the base values as subscripts, then the assumption is that these are decimal values, which they are not. All right. So 3, 4 is really a base 5 value. It's not a decimal value. We had performed the entire division in base 5. So it's important to write the final answer with the subscripts of the base values. All right. So now let's go back to performing the division of the next example. These are two base 8 values, 252 in base 8 divided by 4 also in base 8. All right. So again, the process is the same. We have to pick two digits to start with, 2, 5, and we have to come up with a number in base 8, which when multiplied by 4 should get us, or should give us, a value as close to 5 as possible. All right. So we have to kind of randomly pick some numbers. It's kind of a trial and error process. So I'll start with 4 times 6 perhaps. All right. So 4 times 6 in decimal is 24, correct? So I have to convert that to base 8, to a base 8 values, and I can do that by the bundling process. How many bundles of 8 can we create out of 24? So we can get 3 bundles of 8s, right? So we can get 3 bundles of 8, 16, another 8 makes it 24 plus 0 remaining. All right. So that makes the base 8 equivalent of 24, 3 and 0. All right. So 3 would be the 3 bundles of 8, and this is the 0. This is how we get the 0. So 3, 0 is larger than 2, 5. So this won't work for us. 3, 0 base 8 will not work for this problem. So let's pick the next lower number, which is 4 times 5. All right. So let's see what 4 times 5, which is 20, is in a base 8. Again, same process. I'm going to extract bundles of 8 from 20, so we can get 2 bundles of 8 from 20, that would make it 16, plus 4, right, would give us a 20, right? 2 bundles of 8 plus remaining is 4. So the octal equivalent, or the base 8 equivalent of 20, is 2 bundles of 8 and the 4. So 2, 4. So 2, 4 will work for us because it is close to 25 without going over. Close to 25 without going over. So what I do is I take this 5, all right? The 5 goes up here as part of the quotient. This is a 5. And the 24, which I got in base 8, after converting 20, I got 2, 4 base 8. I'm going to write that below the 2, 5. So, and this is a straightforward subtraction. Nothing to borrow here. So 5 minus 4 is a 1. 2 minus 2 is a 0. The next step, I have to bring down the 2 and repeat the process. What base 8 number, when multiplied by 4, will give us a value as close to 12 as possible? So this time, let me try 4 times 2. All right. So 4 times 2 is 8. All right. How many bundles of 8? I'm doing the conversion. 8 is a decimal value. I have to convert it to an octal or base 8 value. How many bundles of 8 can I create out of 8? 1 bundle of 8 plus 0 remaining. That means the octal equivalent, or the base 8 equivalent of decimal 8, is 1, 0, right? It's 1, 0. So 1, 0 will work for us because 1, 0 is close to 12 without going over. So what am I going to write in the quotient? I'm going to, I'm going to write this 2 up here in the quotient, and below the 12, I'm going to write this 10, correct? So I'm going to write that 10, do the subtraction. Again, straightforward subtraction, nothing to borrow. So 2 minus 0 is a 2, 1 minus 1 is 0. Nothing, no more digits to bring down, so our division stops here, all right? So again, the final answer is written like this. Answer is the quotient first, so 52 base 8 with a remainder of 2 base 8, all right? So this is the correct way of writing the answer, indicating the base as a subscript, all right?